to do some examples of converting spherical coordinates to Cartesian and cylindrical coordinates. So we have a coordinate conversion list, and this is, we'll just, the idea is you keep this and then you use the ones you have to plug in. We could label them, but whatever. So we're going to convert these spherical coordinates to rectangular and cylindrical coordinates. So I'm going to do the rectangular in well, that's purple, in blue, and I'm going to do the cylindrical ones in red. So I have spherical, I want rectangular. Well, these give me rectangular, so I can do x equals sine. This is, remember, this is rho phi, theta phi. So remember, phi is your third coordinate. And so we have sine of phi, rho is 6, sine of pi over 2, and cosine of pi. So that's, anyway, we'll do y is 6 sine pi over 2 sine of pi, and then z is 6 cosine pi over 2. So in that particular case, sine of pi over 2 is 1, cosine of pi is -1. So we end up with -6, and sine of pi is 0, and cosine of pi over 2 is 0. So -6, 0, 0. Now, does that make sense? Well, let's think about this. If the distance is 6, so the magnitude of this thing is going to be 6, so we're good. And if I make an angle of 180 or pi from the positive x-axis, well, that's complete 180 to the negative x-axis. So we should still stay on the x-axis, which we do. There's no y value. And pi over 2 is the distance from the positive z. So if I take that and I go pi over 2, then I'll fall directly from the z-axis onto the x-axis. So we have this piece right there. So that makes sense for what we're trying to do. Now, to convert it to cylindrical coordinates, all right, we have r is rho sine of phi. So that tells me r is 6 sine pi over 2. Again, theta remains theta, and z is the same as in rectangular coordinates. So that's 6 pi 0, which again we tend to agree with, because there should be 0 for the z coordinate, and this has a magnitude of 6, but it's in the opposite of the positive direction. So these coordinates are describing the same place. All right, now to move to this one, we do the same thing. X is 9 sine of pi cosine of pi over 4. Y is 9 sine pi sine of pi over 4. And z is rho cosine of pi. So that gets me, well, sine of pi is 0. So 0, 0. And cosine of pi is -1. So that gets me 0, 0, -1. Or -9. So does that make sense? Well, let's think about it. It has a total distance of 9, which that agrees with that. So pi over 4 is the angle that it rotates out. But then pi, since it goes pi, it starts at the positive z-axis, falls all the way a -100, or falls all the way 180 degrees. So it actually doesn't leave the z-axis. So what you notice is that this pi over 4 actually doesn't matter. This could have been any angle because it would have disappeared in those terms. So this is kind of a bit of a red herring. Now let's see if we can get that same, if we can make sense of it in cylindrical coordinates. So again, r is rho sine of phi. And then we would, so that's going to be 0. Theta is just whatever theta is, so that's pi over 4. And z is 9 cosine pi, so that's 0, 0, negative 9. So those come out to the same coordinate, and they should, because the z coordinate's the same in both systems. So kind of an interesting situation. Finally, let's put this one to the test. We have x is rho sine, again, rho theta phi, sine phi. Y is cosine theta. Y is sine phi. Sine of theta. And z is rho cosine of phi. Now we have these pi over 9s. And, you know, if we were really clever about it, we could try to figure out a way to, because that's going to be what? It's going to be pi over 3 minus pi over 6, I believe is that right? No, it's still not right. But there's probably a way to do a difference formula to get that, but I don't want to focus on that. I want to focus on some intuition here. So pi over 9. We know pi over 9's got to be in the first quadrant. It's 20 degrees. So that tells me that this is a positive number, but it's kind of small. Positive number, but kind of small. Cosine of 3 pi over 4. Well, that's second quadrant, so that should be negative. So what you're going to get is negative 7 over square root of 2 sine pi over 9. And then this case, sine of 3 pi over 4 is in the second quadrant, so that's positive. So that's positive 7 over square root of 2 sine pi over 9. And then you've got this 7 cosine pi over 9. So that's going to be relatively close to 7. And then, so the reason why we want to point this out is that z, we know, is positive. This value is positive, and this value is negative. So that tells me that if we have a negative x value and a positive y value, that tells me that we're in quadrant 2. So that should give us information, or that should help us realize, okay, 3 pi over 4, that's probably the right answer. So converting that to cylindrical coordinates, we want to do r is 7 sine of pi over 9. Theta is 3 pi over 4. And z will be the same, 7 cosine pi over 9, which gets us a coordinate of 7 sine pi over 9, 3 pi over 4, 7 cosine pi over 9. And this matches that coordinate in terms of the values. Because if you take this squared plus that squared, you're going to get that. So we can be reasonably confident we've done the transformation, or we've done the translations there. Now, let's take a case where we take rectangular coordinates and we convert them to spherical. So we have rectangular coordinates. We want to get spherical coordinates out of them. So I have negative 4, 0, 0. So intuition tells me that this is going to have a magnitude of 4, and it's going to be in the negative x direction, and it's going to be on the axis. So that tells me that I should expect z to be pi over 2, because it's coming down and hitting the axis. And I should expect theta to be pi, because it's in the negative x direction. And I should expect rho to be 4. But let's calculate it out and see if we can get the same information from that intuition. So again, rho is square root of negative 4 squared plus 0 squared plus 0 squared, which is square root of 16, which is 4. And then theta is, we're going to just go ahead and say the arc tangent of 0 over negative 4. Well, tangent of 0 is 0. So tells me that theta is 0. Oh, you know what? This is very important. I made a mistake. Tangent of 0 is 0, but we have 0 and we have negative 4. Tangent of pi is also 0. So how do we determine if we're dealing with tangent of 0 or we're dealing with tangent of pi? Well, the reason we should know this is because the x value is negative and the y value is non-negative. So that tells me that I'm not really in a quadrant, but I'm in, if this is quadrant 1, I'm right at the edge of quadrant 2 and 3. So my theta is actually pi. Don't make that mistake that I just made. And so then phi here is the arc cosine of 0 over 4. Now in this particular case, cosine doesn't care about that because cosine is an even function. So cosine of, when we have, my arc cosine of 0 tells me that phi's got to be pi over 2 because cosine of pi over 2 is 0. So that tells me phi is pi over 2, which again is what we projected just by thinking about it. It's not always that easy, but it can be. All right, so now we have this. We have rectangular coordinates. We have -5, and square root of 2. So we know the radius is going to be, or not the radius, we know that rho, the total distance will be bigger than 5. How much bigger, we'll figure it out. But we know it's going to be larger than 5. So if we get something smaller than 5, we've done it wrong. And then if I look at the x and the y, what I see there is that they have the same magnitude. So it'll be some sort of pi over 4. It might be pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. So I know that it's got to be one of those. And then for the phi, what I notice is that I have a negative z value. So if I start here, this is pi over 2. So to go negative in z, it has to be greater than pi over 2. So that kind of gives me a little bit of an understanding of how to get there. So anyway, so from pointing that out, I'd say rho is -5 squared plus -5 squared plus negative square root of 2 squared. So that's the square root of 52, which is 2 square root of 13. Now, from 52, that's going to be a little bit bigger than 7. Square root of that's a little bit bigger than 7 because square root of 49 is 7. So we know that we've satisfied the fact that it's got to be larger than 5. Now for this one, if I do theta, tangent of theta is -5 over -5. So that tells me that tangent of theta is 1, but that could either be pi over 4 or 5 pi over 4. But since that's negative and that's negative, I know that I'm in a third quadrant, so that tells me that theta's got to be 5 pi over 4. And then for phi, well, if I get phi, it's the arc cosine of negative square root of 2 over rho, which is 2 square root of 13, which is the arc cosine of, let me think about this for a second, it should be -1 over the square root of 26, which you don't really have to do. It's not that big of a deal. But the reason you want to think about that is that you know that that's it's negative, but it's pretty small. So if it's negative, it's going to be just slightly below we'd have to plug that into a calculator to figure out, but we know that we're going to get a value that is larger than pi over 2, but just a little bit. It's 2 square root of 13, 5 pi over 4, and negative 1 over square root of 26. So finally, we want to do this one, negative 1 to positive 1. So what I'm seeing when I'm looking at this is that the x value is negative, the y value is positive, so that tells me that I'm in quadrant 2. So my theta is going to be somewhere greater than pi over 2, but less than pi. I know my z value is positive, so theta is not going to be 0, but it's not going to be all the way to pi over 2, so it's going to fall some value above, or some value in that phi is going to be something in the first quadrant. And if I look at this, we know that the magnitude's got to be larger than 2, but how much is hard to say. So I do phi equals negative 1 squared plus 2 squared plus 1 squared, which is the square root of 6, which again is bigger than 2 because square root of 4 is 2. And then theta, tangent of theta, is 2 over negative 1. So that tells me that theta is the arctangent of 2. So the arctangent of 2, but it's not the arctangent of 2. The arctangent of 2 would be in the first quadrant, but we're looking for something in the second quadrant, the arctangent of negative 2. But we're looking for something this is going to give us something in the fourth quadrant because of the way tangent works. Remember, tangent goes from negative pi, arctangent goes from negative pi over 2 to positive pi over 2. So if its range is only that, if you think about your x, y, quadrant 1, 2, 3, 4, then the arctangent's range is only quadrants 1 and 4. It's missing that quadrant 2. So what you're going to have to do is you're actually going to have to add pi to that. And then finally, phi is the arc cosine of the z value divided by the rho value. So 1 over the square root of 6. So remember I said that it's more than 0, but it's definitely not all the way to pi over 2. That's much, much smaller. That's much more close to 0, which makes sense because you're actually decently high overall. Anyway, so your coordinate there is square root of 6, the arctangent of negative 2 plus pi, and the arc cosine of 1 over the square root of 6. Now, in practice, you're probably going to put these in a calculator or get some real numbers or whatever, but it's helpful to think about things symbolically and in sort of uglier answers. And the reason we want to do that is because as you move along in mathematics and start to deal with things that kind of only make sense symbolically, you want to decouple yourself from a calculator and wait until you just have to use it. So think like, a real world example, you're going to compute a number, but we want to get as far away from that until we have to.